Thank you very much. One of the fun things that, about what David, Simone, Josh, and the rest of the Economy crew do is find threads to pull across a number of different topics. And we're lucky to have our own frighteningly smart group of people here to talk about sentient ecosystems. They're all practitioners doing things in the world now, but we'll bridge between what you're doing now to where things might go. So why don't we just start with some self-introductions, if we could. Yeah.
I'm Ken Washington. I'm the Vice President of Research and Advanced Engineering at Ford, and that includes all things having to do with putting technology into our vehicles and into our future mobility systems.
I'm Babak Hojat. I'm the co-founder and chief scientist at Sentient Technologies, where we have massively distributed AI technology that we've deployed in two main verticals, in automated trading as well as in what we call intelligent commerce.
And I'm Claire, co-founder of the startup Auto, and I would say lead on the software architecture of the trucks.
Is it really a startup?
Kind of. I mean, it used to be a startup the last 6 months.
Okay. And what has happened to Auto in the last 6 months?
All right. So Auto was acquired in August by Uber.
So another startup, I guess.
Another startup, kind of.
All right, very good. So we're going to talk about sentient ecosystems. Babak, your company happens to have the word sentient in it, so why don't we start with you? When you hear this topic of sentient ecosystems, what do you think of, and what does that have to do with what you do at Sentient?
Well, we think of AI as going beyond just making predictions off of data. We think about it as making decisions. And when you think about decision making is not this one-time thing. You don't look at data and build a model and then you just run that model going forward. Decision making happens in a loop. And that decision loop, we often talk about the OODA loop. We didn't come up with it. That's John Boyd, the US colonel, looking at what makes for a very successful fighter pilot. He noticed that observe, orient, decide, act. This loop, the faster a fighter pilot can actually run through the loop, the more successful they are. So we've made that a model of decision making. When we talk about sentient ecosystems, we're talking about distributed decision making that is not only based on learned models, but the decision making itself is adaptive to the environment. And there are many, many instances of that already out there where we can enable using AI.
So say more about what those use cases are. What are the things that practically that we're seeing actually happen in terms of, say, physical ecosystems?
Well, in our own experience, there is the case of e-commerce where the first step is building that model, which is based on becoming aware of what is being sold. And that awareness goes beyond just taking the existing metadata on, for example, the items that are on sale, but actually applying the AI to discover the features itself. Something like color, where we already have a terminology for it and so forth. It turns out that if you actually allow the AI to discover that and distinguish that, it is more in line with how us consumers distinguish color as well. So that first step is let's be able to auto-encode the features of what is being sold based on the images or other data that's available. The second is let's learn about how the users actually interact and describe their preferences. It might not necessarily be natural language. It might not be through search terms. It might be simply through viewing what's there and clicking and giving us this implied notion of, I prefer this one more than all the rest. Therefore, where's the trajectory of where this user is going? So that's more in the case of e-commerce than iCommerce. I'm just describing one of our products there. But it could also be in the context of, for example, Internet of Things. All the ingredients are there. You have the sensors. The sensors are usually exactly where your actuators are. And so if you can actually collect the data at the point where they're being sensed, make the decision right there and then, so you don't waste time moving everything you've learned back to a server side and processing and so forth and sending it back. So you can actually make some decisions at the point of need already and sending those decisions to the actuators. But then you can abstract bits and pieces of that might be useful for cohorts of these actuators as well out in the field. So that's another example of how these decision-making loops can be distributed onto not just our homes where we have a lot of Internet of Things, but in agriculture and industry and a lot of different.
Or maybe even vehicles.
Great segue.
Ken, is my Ford? I don't have one right now, but is my Ford Focus sentient?
Well, it's not today, but it could be, and it will be in the future. And I love what Babak is saying, because that's exactly what's happening in the automotive industry. If you go to Webster and look up sentient, it'll tell you that it means responsive to or conscious of sensory impressions or just being aware. And so you think about it, we spend a huge amount of our time being mobile or in our vehicles or in some other form of transportation, moving from one place to another. And whether you have a Ford Focus or any other kind of vehicle or use public transportation, wouldn't it be wonderful if that journey knew you and was responsive or aware of who you were, what your choices are, how you need it and want it to move? And wouldn't it be also great if it was much more aware of the surroundings? What's happening today, because sensors are getting cheaper, computing is getting better, software is getting much more capable, all that's being stitched together to make the promise of autonomous vehicles and smart vehicles with sensors in it that know us, and sensors that can help us have those kind of journeys. That's approaching sentient, but it's not quite the kind of sentient that we have as humans, because we have these amazing sensors in our bodies that are very difficult to replicate, including our brains. We're getting close with the kind of machine learning and the kind of artificial intelligence that we can put into our algorithms that are making the autonomous vehicle of today and tomorrow. And it's a really exciting future, because you think about it, what other sensors in our lives are as large and has as much power as a vehicle? There's a lot of electrical power. There's a lot of space for many sensors, and that's exactly what we're putting on our vehicles. Auto's doing the same thing. They've got LiDAR sensors that can look out to a couple hundred meters. We can put microphones that can hear the environment. You can put radar and cameras that can see 360 degrees around the vehicle. And all of that can be processed by some of the fastest computers in the world, and then it can respond so that you can get to where you want to go safely, autonomously, and smartly. That's exactly what's happening in the automotive industry. We're not there today, but we're moving there really fast.
So a lot of us like the idea of autonomous vehicles. Why do I need to get beyond autonomous to sentient? I mean, how much more benefit does it give me to have my Focus know me?
Well, it's not just about the vehicle, because it's about your experience, right? So think about it. When you're getting your vehicle and you type in your address where you want to go, why in the world do you have to do that? The vehicle should know, because it's in your calendar, right? And every time you get in your vehicle and it's cold, you turn on the heater, you turn on the warmer for your steering wheel. It should know that, because it's cold outside, and sensors can tell you that it's cold outside. And so, no, you don't have to go beyond autonomous, but if you've got this capability there and the processing is available, it's absolutely the right thing to do from a user experience point of view, is to stitch all that together to make it a better experience. Because it's not just about the vehicle. We all live in homes that are now getting connected and getting smart. We all work in offices that are connected and smart. And those are the three places we spend most of our time: at home, in our car, and then at work. And if all three of those experiences can be stitched together smartly, you'll have a much better experience. It'll be safer. It'll be more fun. That sounds like a great future.
So for some people, their work is in a truck, I understand, and Otto works in trucks. Is there anything different about trucks versus other vehicles that we should be aware of?
So I would like to, I think the main difference would be probably the first impact, I would say, in the first years. Because if you look around you, everything that is in his room, or that you wear, or that you have with you, was brought by a truck at some point in time. Everything, all our economy is actually like about transportation. We transport goods everywhere from like one place to another one all the time. And the funny part is, like, if you look into the detail, of like how we actually schedule the transport of the goods to one place to another one, it's actually terribly inefficient. So there's a lot of like, you can see like a truck carrying wood going in one direction, and with another truck also carrying wood going at the exact opposite direction. And so what's like the impact of the technology on how to bring more sensing to all the industry, it's going to be as multiple dimension. So I would like to start I usually compare like, for instance, computer science or phones. Why are we so addicted to them? Why did they have so much an impact on our life, on what we do and how we organize our life? Well, because they have a lot of inputs. When you think about it, they can make decisions because they do have the inputs. If you don't have inputs, you cannot make decisions. And when you look into like what's happening right now with IoT or with cars, it's all about these inputs. It's like we are starting to equip the environment and to collect information about what's going on around. So if you look, for instance, at your phone, how many inputs do you have? You have the calendar, the geolocation, the Wi-Fi signal, your emails, your history. You have a lot of inputs that know about you, about what you are doing, and can get like informed decision about what to do next. However, in terms of cars, even if we start equipping with like more and more sensors, we still have like one camera, one GPS, maybe a LiDAR, and a radar. So it's still like very little information. So if you start coupling information with like infrastructure, then you can start basically saying when the truck would need to stop, or when the car would need to stop, or because there is a red light, or how many cars pass by around like on this highway. And so so when you start collecting this information, suddenly like you can make much better decisions. So for transportation of a passenger, it would be knowing first where this person wants to go, but then after that, how do you plan the best way to get to another location, to get to the destination? For a truck, it's even more complex because you are actually carrying a lot of goods that each single part of the goods in the truck have a specific destination and a specific life cycle. It needs to go somewhere, and then it will have to go somewhere else, and then it will have to be transported and like split into different pieces, and then like the last mile problem, like this final one will arrive at your doorstep. So like I think this is where like for trucking you have so much possibility to actually make the whole system of like good delivery more efficient, which means like more yeah, of course, like planet-friendly and eco-friendly, and so I would say that the scope of the trucking is absolutely tremendous.
The opposite of the traveling salesman problem for people who remember. Anyway.
Optimization problem.
Yeah, exactly. So the thread that I'm hearing from all of you, right, is this idea of sensor data, making better decisions, oftentimes in real time, basically the combination of the physical world and the virtual world in order to create what you might call a sentient ecosystem. Ken, when we were talking earlier, you said, that sounds cool, but it could be creepy at some time. So say more about what that might mean.
Yeah, well, there are a couple of potential potholes in that future. One is...
Says the car guy.
Yeah, well, I use that term intentionally because we often don't see, and we ignore the seriousness of some of the downsides of embracing technology. And one of the fairly important and very serious potholes in that future is cybersecurity, because there's a lot of information available, and you're sensing the world, and it creates a much larger attack surface and threat surface for people who have malintent. And so as the designers and architects of millions of vehicles that will become now nodes on the Internet of Things and will become these near sentient movers in a sentient ecosystem, it's very important to us that we address this cybersecurity issue and take that on with the seriousness with which it deserves. So we have a team of experts working on that. The second pothole that's important is this whole area of privacy, and it's very different than cybersecurity, and it's important to not mix the two, because the data that will unlock the sentient kind of behavior and the kind of user experience that people dream of is the kind of data that car companies like Ford don't own. You own it, right? The consumers own that data, and you have to give us the permission to process it. And what's in it for you? Why would you ever do that? Why would you give us that kind of permission? Well, you do it every day, and when you use your cell phone or you use a free internet service, and you do that because there's an economic value. There's a bargain. You do it because the provider of that service is giving you something in exchange that is worth it to you. And they're giving you their assurance that you can trust them to manage that data in a responsible way. And so our role in building the autonomous, connected, smart car that's going to give you a great user experience is to have the kind of trust in the environment to give you the sense of trust that not only are we going to protect that data and treat it fairly and responsibly, but we're going to use it to create some good for you. Because otherwise, why would you do it? And so this sentient ecosystem is part of that economic value equation, where we're going to give you something good back in return that is going to make your journey faster, more comfortable, and certainly safer, because 30,000 people die every year in a car in the United States. And that is almost all avoidable because it's mostly driven by human error. And most of us don't have eyes in the back of our head, and we can't see out to 200 meters, and we can't process information at the kind of speeds that an autonomous vehicle can process it. And so we're pretty confident that with the right amount of development, testing, and validation, and on-road and simulation kind of evaluation, we can put an autonomous vehicle on the road that is going to be safer than a human driver. And with
when's that happening?
We plan to introduce that in a high volume ride service in the year 2021. And so this is not like 10, 15, 20 years in the future. This is in our imminent future. And in 2018, we're going to have it in prototype form on our campus, testing and evaluating it. We're going to have 100 vehicles out on the road testing and evaluation. Uber has them on the road today with safety drivers. And so this is happening very quickly.
Why are you so far behind?
We are absolutely not behind. We're choosing a different method and approach to test our vehicles using our own engineers, not using riders. But no one way is right or wrong. It's just different. We're in a different business. And so our approach is going to get us there in 2021 in the way that creates that trust that I talked about, and it gives you that kind of value back in exchange. That's really the way you're going to get through these potholes, because these are very serious concerns and challenges.
Let's jump into one of those potholes. Amongst other things, you're a privacy expert. Do you have voice in the car?
So today we do have voice in our car. I mean, it's part of our safety mandate to help our drivers keep their hands on the wheel and eyes on the road, so you can talk to your car instead of looking down and fiddling with knobs when you're going 60 miles an hour. You can do some pretty simple math, and the math will tell you if you're driving 60 to 70 miles an hour, you can't afford to look down for more than about a second. And so we have voice recognition in our vehicles. So that's only going to get better as we implement machine learning and advanced algorithms in our vehicles. So absolutely.
So should that freak me out? My car is always listening to everything that I say in my car.
Well, it should only freak you out if you don't believe the bargain that we have given you, which is we will never sell your data without your. Number one, we'll never sell it. Number two, we'll never use it without your permission. And our second part of our bargain is we use it to help make you safe and to give you a better experience. That's why we need it.
Yeah. Bob, your thoughts on data and how people should feel about it being used, particularly as it enables the environment around us and is watching us all the time?
Yeah, I think we should be careful. Absolutely. We should seek some sort of value from the data that we share. We are sharing data. I mean, I think sometimes someone was telling us, I think we were talking to Oxford at some point or other, they were saying, yeah, we anonymize the DNA data that we collect. And I was like, how do you anonymize DNA data? Right? I mean, that's,
do the customers who you're optimizing their e-commerce experience know the data that you have about them?
That data is definitely anonymized, and it's so here's one thing that's interesting about a decision cycle. If you're actually fast enough in learning and responding within the decision cycle, you don't even have to move that data around, right?
What does that mean?
For example, in the case of a car, that data stays in the car, it's processed in the car, the AI is actually running in the car. If anything leaves the car, it's abstractions that are much less specific to your behavior that might be useful across some classification of users. So for starters, that's, I think, the trajectory we're going down, so that should be some comfort. There's also cases around, for example, cybersecurity. I mean, we just had recently this case with huge DDoS attack where IoT was actually involved. Well, there is one of the research projects we're doing at Sentient is, in fact, looking at AI being able to predict and protect against DDoS attacks in a distributed manner. Because when you think about it, these DDoS attacks happen very rapidly. They're very, very distributed. And the best way to actually protect against them is to very quickly identify them, again, in a distributed manner, and be able to actually prevent them in a distributed manner. So as I always say, I mean, yes, these threats are coming, and some of them are driven by our eagerness and to actually deploy these new technologies very quickly. But our best, best way to protect against those risks are the technologies themselves as well. So if we're smart enough, the AI itself can protect us against those risks, I think.
You said something else really important. I have to build on this. It's like you said, data doesn't have to leave the car unless you need it for some other purpose to connect the dots. That's really important. And another piece of protecting ourselves and of responsibly using the data that we're entrusted to is to implement great practices. You don't have to store the data longer than you need to in order to deliver the service back, right? So for example, you could store the data and just keep it hanging around, but why would you do that, right? You shouldn't. And so there's some just industry best practices regarding how you code things, how you process data, how you move it around, how you secure it, how you encrypt it, who you share it with, how often you share it with, and how long you keep it, that will actually help address some of the concerns and issues.
Let's bring up another topic that comes up a lot. Claire, for you, I can mention the number of people who are tragically killed every year. And so safety is one of those trade-offs that you can get from deploying these technologies in a vehicle, a light truck, a heavy truck, et cetera. But there are questions that the software has to, questions about the decisions that the software has to make, which are embedded ethical questions. So there's the classic, the famous trolley problem. You're a head of software, and I believe you are also a robotics expert, so there's a long history of questions about how robots should make decisions. So Auto Truck sees a political candidate 1 and a political candidate 2 has to choose which one to run over.
Which one's one and which one's
so,
two?
very often, I like this question because very often it assumes, it's like a very philosophical question, like human will make this kind of like ethical decisions. It's almost like you are involved in a car crash and that a human like basically is actually given the choice between two like scenarios or outcome. So most of the time, beside a professional like racing driver, like humans are already like very not equal in terms of like how they react to things, and it's also very like when something happens very fast, it's actually very rare that you can make any kind of ethical decision. Because it just happened too fast, and your brain cannot process the information. What like the machines have has a big advantage to us. It's first, they blend different kind of sensors. So they they don't only have RGB cameras here, but they also have a radar that can see through snow and through rain, through very heavy fog, and LiDAR. And the decision cycle of a car is actually 10 times faster than a human. So, like, I guess, like, we would love to. I think that these questions come from the fact that we would like the machines to be better than us and do like more and better, not in terms of like technicality, but in terms of like they should bring more love in our world, or they should make this like hard decision that we would not like not to do. But the reality is like machine cannot do that. Machine will like never like make this kind of decision because they are programmed just to be able to like make the best decision at one particular moment. And this is why actually we can rely on them, because like if machines were actually, if your phone in the morning like tells you like, well, I feel you are not very happy today, I'm not gonna turn on, so that you're not gonna be able to read your emails, or like, you know, like makes your life like different for a day. Well, we would not feel like it's a very good idea. We will throw like the phone away and say like, this machine doesn't work. Same thing for the autonomous cars. They will make the decision faster than us, but we cannot expect machine to do ethical decisions for us. Like, unless we program them, of course. But at some point, somewhere, someone would have to make the decision, would have to make the call. The machine will not decide it by itself. A programmer would have to make this call, which goes back to like, why would this person be more qualified to make this kind of decision than any other individual? Or like, who should make this call? Who should like decide what is the ethical correct answer?
So you're in charge of software for auto, so I think you're making the decision, right?
Or some intern.
So, like, I wish it was so easy, but unfortunately, like, so how does an autonomous car works? Well, you can see obstacles. You can see. You can only see things that you teach your car to see. Let's say if the car or the truck suddenly see an elephant in the middle of the road, it's very unlikely that the car is going to decide this is an elephant. However, it's going to see there is an obstacle on the road, and that it's going to have to decide to brake for this obstacle. So whether a particular scenario should be done for this elephant, I think the best course of action in any cases should be to find the most safest path around the obstacle. There's no like the question of like balancing between two decisions is like a very infinitesimal part of the scenario, of the real scenarios that are going to happen.
Just real quick, two points here, just to build on what Claire said. First of all, here's the good news. If a car is in a crash, or any AI is in some situation in which we have to interrogate to see what happened, we have a log. This is machinery that is logging every single situation up to the point where, let's say, there was an impact. And even in some cases, with some AI, it's harder when it's black box versus declarative, but we even have what data went in to cause some sort of a decision. So we can actually go back and look at exactly what happened. And of course, okay, maybe what happened is not what we really desired, but now we can fix for that. We can't do that with humans.
Right.
So, we can't even trust what they say. They probably forgot everything because they were in a shock, right? So that's one thing I wanted to bring up. The other thing I want to bring up is this question of cultural sensitivities. Okay, a while back I was called by this reporter to comment on this Google images thing where they had mistaken an African-American lady for a gorilla. And they were asking me, what do you know, why did the AI do that? And I think Google's excuse was really lame because they said, well, we need more images of gorillas. Well, the fact is, you know, if the AI had mistaken a gorilla for a chimpanzee, nobody would have had any issues with that. This is a very culturally sensitive issue here, and it's not built into that AI. And it's kind of second thought. And in fact, when you go back to see how you can fix it, instead of thinking, well, where should I put my emphasis? You're just thinking, well, I'll just put more data in that. I think that's the wrong approach. So just wanted to bring that up as well, which is you know, the ethical and cultural models that are pretty much non-existent right now should be taken more seriously.
All right, so we've raised a lot of interesting issues for people to talk about during the coffee break. Now it's...
But I got a comment.
All right.
All right. Hey, this is Techonomy, so I can jump in. Look, I think that's really kind of not the right question, because it deflects us from what I think is the much more important question, which is how many more situations like that have we avoided? Because we've got vehicles on the road that can anticipate that situation is coming, and you'll never be in it. That's the comment. That's the point, really, to make.
All right.
Because you know, we're faced with trolley problems as human drivers because we allow ourselves to get into them. And autonomous cars won't do that.
Prevention. That's good. Okay. All right, quick, lightning round. Here we go. In what situation did you come closest to feeling like you were in a sentient environment? Ken?
In my smart home, when I walk into the rooms and the lights come on and I leave and the lights go off and it plays my favorite music.
Babak?
Every time I open my cell phone, yeah.
Claire?
Every time I take my computer.
In what situation did you feel most creeped out by something that seemed like a sentient environment? Claire?
Every time I take my computer.
Babak?
One of the joys of AI are these delightful moments when the AI actually does something that you never anticipated. So it happens a lot when you're practicing AI.
And that's when you're creeped out. Okay.
Yeah, sometimes.
For me, it was the first time I took a ride in the Ford autonomous vehicle. It was so good. It was creepy, quite frankly.
All right, that's good.
Yeah.
With your preferred voice interface, what name would you give it?
I don't know. Freddie.
Babak?
I think I've already. I mean, Siri was.
I would not use voice interface. I would wait for mind interface, brain interface.
What movie best depicts a sentient ecosystem? Claire?
Matrix?
I would go with Her, but that's just me.
The Matrix.
What technology is most pivotal to getting to a sentient ecosystem? Ken?
Machine learning.
Babak?
Pass.
Come on,
you can do that.
Guy.
This is Techonomy.
Interfaces.
What company other than your own is doing the most to enable a sentient ecosystem? Claire?
What, sorry?
Company. What company is doing the most to enable a sentient ecosystem?
Other than your own.
Other than your own.
It's a combination. I think Apple opened the pass, actually.
I would say Google.
Facebook.
Finally, Ken, what is the use case you can't wait to happen involving sentient ecosystems?
When I think it happens. Brain-machine interface.
Not having to be within the decision loop of, you know, responding to email and text and, you know, all the distractions that my cell phone provides me every minute of every day.
Claire?
Yes. I have a machine doing all the boring stuff for me, I would say, and in the far future, it would be that I don't have to travel anymore. Or I travel just to like enjoy the travel, but I don't have to move anymore. Holodeck. And I can do everything remotely.
It's like holodeck.
Very good. Please thank our panel.
Thank you, Michael. Nice